The president takes a hard stand against any kind of cloning, whether to make duplicate people or to understand disease. But that cloning could provide the stem cells that this man so desperately needs.
His symptoms will continue to progress.
The directions for a human being are written in code, 3 billion letters long. These instructions tell our bodies how to live, how to grow, how to die. Researchers call this code the sequence.
This is Secrets of the Sequence. I'm Lucky Severson. Again, arguments in the political arena are echoing in the halls of science. And again, this week, with the help of our electronic guide to the genome, we'll try to provide some perspective. This spring, the President of the United States met outside the White House with a group of 200 lawmakers, religious leaders, bioethicists, scientists, and patients. He called for a ban on human cloning.
Science has set before us decisions of immense consequence. We can pursue medical research with a clear sense of moral purpose, or we can travel without an ethical compass into a world we could live to regret. Science now presses forward the issue of human cloning. How we answer the question of human cloning will place us on one path or the other.
Cloning. You probably heard the term 50 times. Even the new Star Wars movie is called Attack of the Clones. So let's start at the beginning by defining our terms. Computer, can you give us a simple, understandable explanation of what cloning is?
Yes, Lucky.
Okay, you have the floor, or the table, or whatever.
But in the present context, there are two kinds of cloning: reproductive cloning and therapeutic cloning.
Start with reproductive cloning.
Human cloning is the laboratory production of individuals who are genetic copies of other human beings. All the genetic information necessary to produce a human being is contained in the nucleus of a person's cells. Remove the nucleus from a human egg and insert a nucleus from another human being, and theory says when that egg is implanted in a woman, it will develop into a duplicate of the donor, a clone.
Back to the president.
Human cloning is deeply troubling to me and to most Americans. Life is a creation, not a commodity. Allowing cloning would be taking a significant step toward a society in which human beings are grown for spare body parts and children are engineered to custom specifications. And that's not acceptable.
The spare body parts the president refers to would come from stem cells, another term that's been floating around for months and another term in need of definition.
Stem cells are called that because they are the cells from which all other cells grow. After a human egg is fertilized, it begins to divide almost immediately. By day 4, the embryo has become a hollow ball of about 300 cells no larger than the head of a pin. This is the blastocyst. The cells on the outside of the ball will go on to form the placenta and supporting tissues for the fetus. On the inside of the ball is a clump of embryonic stem cells. They have the potential to become virtually all the cells and cell types in the human body, from skin cells to blood cells to liver cells to brain cells.
But the blastocyst is an early stage of an embryo. If it were properly implanted, it could grow to become a new individual. To harvest the precious stem cells, the embryo is destroyed. Creating blastocysts to produce stem cells is sometimes called therapeutic cloning.
Research cloning would contradict the most fundamental principle of medical ethics, that no human life should be exploited or extinguished for the benefit of another.
The same day as President Bush's announcement, 40 Nobel Prize winners wrote a letter and published it on the web. The group approves banning human cloning, but strongly supports therapeutic cloning. They call it a new and powerful approach to understanding the genetics of a variety of cancers and neurological conditions like Parkinson's disease. Parkinson's disease, named after the doctor who described it in 1817. It took nearly 150 years to learn that the illness was caused by the death of certain brain cells, the cells that produce the chemical messenger dopamine. Without dopamine, the parts of the brain that control movement can't talk to each other. A tendency to get Parkinson's disease can be inherited. That accounts for less than 10% of the victims. Does a toxin in the environment cause it? Is it caused by physical damage to the brain? We just don't know. William Abernethy, a minister from Wenham, Massachusetts, has been at war with the illness for 20 years.
Hi, nice to see you. Come on in. Hi, nice to see you.
It's time for a checkup from his neurologist, Dr. David Standard, at Massachusetts General Hospital in Boston.
All right, so how have you been doing?
Pretty good.
Yeah?
Some ups, some downs.
What's happened since the last time we talked?
Dr. Standard specializes in Parkinson's. He's been tracking Abernethy's condition for several years.
3 days.
Uh-huh. Did that make any difference?
No.
No. Once the dopamine's gone, you get all the symptoms of Parkinson's, and those are tremor, stiffness, slowness of movement, and trouble walking. Okay, well, let me take a look at your walking. Come on over this way if you can. His condition will continue to get worse over time. He's now around 68 years old, and his symptoms will continue to progress. He's having a great deal of difficulty walking at this point, and within a year or two, if we don't find something new, I suspect he won't be walking at all.
For Abernethy, Parkinson's has had a devastating effect on his life.
Preaching has been a challenge. I have trouble writing. My grandson, Christopher, almost 5 years old, says, "Why can't Papa come out and play?" And playing means running down the street as he rides his bicycle or his scooter, and can't do that.
Parkinson's afflicts more than 1 million Americans, and there is no cure. Drug regimens help relieve symptoms and may work for years, but they produce unpleasant side effects, and in the end, they only delay the inevitable progression of the disease. Abernethy has tried everything, including surgery to implant an electrode deep in his brain to get the dopamine flowing again, but even that has produced limited results.
I would say that the deep brain stimulator has helped perhaps a bit, but it certainly hasn't been a dramatic improvement in this particular situation. It's in fact even unclear how much benefit you've gotten from that. And you still have a lot of trouble, and I think if there was a stem cell therapy that I could offer to you today, I would offer it to you, and then it would be up to you to decide whether you had that or not.
Sign me up.
Reverend Abernethy thinks stem cells are worth a try, and he thinks it can be done with respect for the sanctity of human life. He would use the extra eggs that are produced in fertility clinics.
What I understand is that a lot of the stem cells can be taken from embryos which in effect are discarded after an in vitro fertilization effort. And to pick those up before they're thrown into the garbage can, and after they've been used or handled to see whether they need to be used or want to be used, doesn't seem to me to present any ethical problem.
An implant of stem cells could replace his malfunctioning brain cells and reverse the disease, in theory. Ole Isakson of Harvard Medical School has developed a stem cell therapy for Parkinson's disease, and it works on laboratory rats.
What you see here is a rat brain with the left side and the right side. The left side has a normal amount of dopamine, this very red color you see. On this side we created Parkinson's disease, and it was only blue, so there was no red on this right side.
Isakson implanted embryonic stem cells into the brains of rats with Parkinson's disease. He hoped the stem cells would transform into new healthy brain cells and produce a missing dopamine. They did. Scans of rat brains showed that the stem cells had indeed integrated with the rat's own brain cells. Ole Isakson has cured Parkinson's in rats. Now the trick is to do it in humans.
I'm absolutely convinced that you can do this in humans. The question, just like with any new technology, is how well and how reliable this will be. We need to do a lot of research to learn all the details and all the safety aspects of this procedure to really be helpful to a large number of patients.
The Secrets of the Sequence teaching materials were developed at Virginia Commonwealth University with funding from the National Academy of Sciences and the Pfizer Foundation. The original public television series, Secrets of the Sequence, was produced by Ward Television with funding from Pfizer, the Pfizer Foundation, Oracle, and the Council for Biotechnology Information. Special thanks to member institutions of the Series Advisory Board, consisting of Virginia Commonwealth University, Harvard University, University of Wisconsin, University of Michigan, University of California at San Francisco, and the MRC Laboratory of Molecular Biology, Cambridge, England.